Thanks for tuning into this webinar. Today, we're going to be discussing SNA, social network analysis, and more specifically, the features within Kumu that allow you to perform social network analysis. One of them is called metrics, and the other one is called a community detection. So first, just to start a little bit on social network analysis. So with Kumu, we're always aiming to reduce complexity. We're trying to tackle tough problems. And social network analysis specifically looks at networks, and it looks at complex social problems that may result from networks. So this can be in society, this can be in an organization, this can be in your community, even in your neighborhood or in your family. All of these are social relationships, and we're trying to analyze how people are connected and how they share things, how they work together. When we're looking at networks of people, we're really looking at a couple of different things. The first one is, how does information spread? So who talks to whom? How close is their connection? How long have they been talking? What kind of information do they share? The second one is, how does work get done? So specifically, if we're looking at an organization, we're wondering how the work gets done, because traditional organizational structures, traditional hierarchies aren't always exactly how the work gets done. Sometimes people will talk interdepartmental, or they'll talk to someone else other than their manager. So there's a lot of ways that work can get done in a more informal structure that you might not see initially if you're working for the company or if you're looking at the company as an outsider. Then the third thing that we try to uncover when we're looking at networks of people is, who are the silent leaders within companies, but also just in communities or even in families. You might think that a person is a leader just because they were put in that position, but sometimes there's also something that we call informal leaders, the silent leaders. So the people that a lot of other people in the network turn to, that might not be that obvious in the beginning. Why do we perform this specific SNA? To identify these leaders, as I just mentioned. The second one is to break down silos and evaluate how the relationships progress and change over time. These three are kind of looking at, how do you increase the impact that a certain network has. Then we also look at SNA to create stronger connections, to create a stronger sense of community. How can we accomplish that? And the last one is how to improve organizational performance. So if we're looking at organizations specifically, you might want to see how to uncover the informal structures, as I just mentioned, or how to increase effective collaboration between people, and eventually even look at stakeholder management. So who are your stakeholders? How do they relate to your organization? And how can you make sure that they're on board with whatever you're trying to do? For social network analysis, there's usually three simple steps. The first one is collect the data. Make sure that you have all the data on your network. Who is in it? How are they connected? What is the information? The second one is to interpret that data. So this is what we're looking at today. Once we have that data, how can we perform social network analysis through the metrics in Kumu? And the third step is to act upon it. So the data that we will get from the metrics calculated in Kumu allows us to make certain conclusions, or to interpret how this network works. And then based on that information, we want to act and look for any of the purposes that we just mentioned, in terms of finding leaders, or making a community stronger, or even solving a complex social problem that we haven't been able to tackle yet. Before I go into metrics, let me just explain what we're looking at right here. In the Kumu docs, if you go here to the heading of disciplines, there is one called SNA network mapping, and all the information that I'm going to discuss today, you can find here again. So it's always good to kind of reference back this document as you're going into social network analysis. There's also a really neat presentation that our CEO, Jeff, created to kind of explain what social network analysis is and how you move along all these steps. So I highly recommend to look back on that whenever you're really starting your own network analysis. Kind of the general guide that I always refer to when someone wants to perform social network analysis. More specifically, today we're going to be playing around with metrics, and that one has a separate guide because it explains really how to do that in Kumu. I'll also show you how to do this in real time, but at least you can always look back here. And especially for any of the terms or the terminology that I'll be using today, you can always find that here. Then let me show you a couple of maps that use social network analysis or that use metrics. What I always say is that metrics is really an unbiased way to analyze relationships, because especially if we're a part of that community or a part of the organization or a part of the network, we might think that how we know the network or how we see the network around us, that's the way it is. So in a sense, that's quite biased, right? Because it comes from our own perspective. But metrics, because it's calculated with algorithms, mathematical algorithms in Kumu, it provides us with a more unbiased way to analyze relationships. So here is the first map that is using metrics. And in this case, they're doing that by a very simple SNA dashboard. This is really the most simple way that you can use metrics. So you can find that here in the bottom right corner. Basically, how many elements does this network have, how many connections, and what is the average degree. An SNA dashboard is something that you can add to a map if you'd like to see that, because it also updates as soon as you're making changes to the view. So if I take activity out, you can now see that the elements and the connections and the average degree have jumped to different numbers. And that kind of allows me to reevaluate the network that I'm looking at, even when I'm taking out certain elements within the network. So if I go to the guide on SNA dashboard, I'll show you again in real time how to do that later. But you can see here all of the different options that we have. The one that we were just looking at was average degree. You can find that here. Average degree in this case was 11.69. And you can see here that that means it calculates the average number of connections across all elements in the network. So in this case, we can say that basically each element in this map that we're looking at has between 11 or 12 connections. Some might have some more, some might have less. But yeah, that's just a quick snapshot of metrics that you can use. Then the other map where social network analysis is a little bit more extensive is this one, because the creator chose to add some more information through the SNA dashboard. So as you can see, this is quite a complex map. When I'm just looking at this, first time I'm opening this, I can't even count how many elements there are just because there's so much overlap here. So now I can easily see, okay, there's 325 elements, there's a little over 2,000 connections. And here we're looking at certain terms: density, reciprocity, the diameter, average degree, the one we just mentioned, and average path length. Again, you can find here in the SNA dashboard what all of these specifically mean. And then you can also decide, okay, in my own map, when I'm creating a map, I want to include this metric and I want to take the other metric out based on the story that you're trying to tell or the point that you're trying to get across. And then the last example that I have here is this one. This is a network of schools. Here we used the metrics to also size the elements based on the metric. And what that means is that you can easily see, based on the sizing, who the leaders are in your network. So for example, if I click here on degree, the elements are being sized by degree, and degree basically means how many connections does one element have. Doesn't matter if it's incoming or outgoing. But you can see now that these larger circles are the ones that have the most connections incoming and outgoing. And usually what Kumu does automatically with the layout is that the more connected or interconnected elements are placed in the center, and the least or the lesser connected elements are placed on the periphery. And you can see that here, right? You see a lot of interconnection here, and then here on the outside there's all these elements that only have one connection to another element. So that's done automatically. So normally you would say, okay, so the people that are in the center, or these elements in the center, are the ones that are the most well connected and thus the most influential. However, in this case, we can also see that there's two quite large elements here, one here, the purple one, and one here at the bottom, that also very well connected. So that allows, kind of seeing this allows us to draw certain conclusions. Because, for example, when I'm looking at this, I can say, okay, so if I'm trying to reach the wider network, I might reach out to this cluster here, so like to these people here. But if I'm looking to incorporate or get my stakeholders on board that are in this group, then I might just reach out to this person because this person is the most influential for all of these. So that kind of allows me to see, okay, who do I want to reach out to, or who maybe has like more power than they should have? Because you can imagine that this person or this school in this case might have some more power over the inflow of information that is distributed to the rest of this cluster right here. And then here, if we're looking at betweenness, it measures how many times an element lies on the shortest path between two other elements. In general, elements with high betweenness have more control over the flow of information and act as key bridges within the network. They can also be potential single points of failure. Yeah, this kind of looks at the same data from a different point of view. And now you can see that actually these elements, which just now were quite large as under degree, they're now a little bit smaller, and now these ones in the center have become larger again. So depending on what I'm looking at, am I looking at just purely connections, or am I looking at how many times an element is on the path between other elements, or am I looking at influence over the rest of the network? All these different metrics give us answers to different parts of the data and different contexts. So what I usually do is I like to play around with that. I like to use multiple metrics. And also, as I mentioned before, based on what I'm trying to do, like the point of the mapping that I'm trying to do, I will choose different metrics. This is just an example of how you can look at these numbers, but then also size to get some more information about the network. And then lastly, what they also did in this specific map is community detection feature. And then they colored the elements based on the community that was given. So I'll show that again in real time. But basically here you can see that this is one community because they're red. And then this is one community, the purple and the blue. And then the larger community that kind of spans the whole network, which is dark blue here. Same for this purple. You can kind of see it's moving towards the center. So this community has very unconnected elements here at the periphery, but it moves inward more. So overall, this community is pretty well connected to the rest of the network. When I'm saying community, I just mean like sub networks within the larger network, subgroups within the larger group. So those are a couple of examples what can be done with metrics. A lot of times when you're looking at a Kumu map, you won't actually notice what has been done with metrics because it's very much a behind the scene type of thing. But if done well, it really informs the story or the narrative that you're trying to convey with your map very well. And you can make sure that your viewers see the system or the social network in the way that you intend to with your map. If you're looking for more examples, we have a project called Projects in the Wild. If you search on kumu.io/kumu/projects in the wild, you can find it. Is a compilation of projects that our users created and that we encountered in the wild. So basically we saw it somewhere, we didn't know that it existed, and then we added it here to show some great examples. And what you can do here is you can search by any of these filters. What I in this case would recommend is that if you're ever looking for a map with either metrics or an SNA dashboard, just click on the drop-down Kumu features and move down to either SNA metrics. If you click here, you'll see any of the maps that have SNA metrics, but we can also choose SNA dashboard specifically. You can also choose any of the metrics specifically, like MICMAC, which I'll go into in a moment. If you're ever looking for some examples, it's always good to check out Project in the Wilds and see if there's a map out there that's already done what you're trying to do. Let's now go into actually doing some SNA ourselves. There's a lot of different types of metrics that I already touched upon earlier, but you can find all of them here. When you're trying to perform social network analysis in Kumu, you can also find all these explanations directly in your project, in your map. This is some data that I already had, and I'm going to download this to Excel. Okay, then I have already created a clean project. If I click on the plus button at the bottom, I can import and I can choose to import my file here. I can also just from my browser instantly drag this to the map. Kumu is now doing a review, basically checking out the elements, checking out the connections, and seeing if there's anything wrong. In this case, there isn't. If you have any issues with importing your data, we also did a separate webinar on importing data. And we also have extensive guides on how to structure your data and how to import it. So I won't go into that right now, but just know that Kumu always does this step before importing data. Okay, so these are all the people in my network. You can see again that there's kind of like a spaghetti in the middle of highly interconnected people. And then there's, of course, always the periphery where some of the lesser connected elements like to hang out. Then if I want to perform social network analysis, I click on this little chemistry hourglass right here where it says metrics, and I can choose between social network analysis and community detection. Let's start out with social network analysis. A little bit of an intro. It helps you discover key players within a network based on their relationships. And then I can choose a metric. As I mentioned before, if you click on any of these, you'll get a little bit of an explanation about what this metric does, and then you can choose which one you want to do. But let's just start with degree. A reminder that degree is the amount of connections that each element has, whether they're incoming or outgoing. And if I click, the ranking is already here, but you would normally click discover the connectors and the hubs, and then you get a ranking here. Just from looking at this, we can see that James is the most well-connected person in this network. If I hover over his name, we can find him. There's James. And he has 19 connections, both incoming and outgoing. Then, of course, Josh second, Jane is third, and so on. This is just very basic information. So we might now say, okay, James is probably very influential in this network based on the information that we have right now. However, as is mentioned here, elements with high degree are the local connectors, but aren't necessarily the best connected to the wider network. So let's see if that is true from the other metrics. Before I go into that, whenever I run metrics, this information is now saved in the profile of each element on the map. So if I now click on this one, Camilo, I can see now that the degree is 13. Degree is 13, and this is the metrics last. So basically the very last thing that I've calculated with social network analysis is what shows up here. This information is now just a part of the profile. If you want to take it out, you would have to actually delete it because it's now here. And it's very useful when later on you want to size based on this information. Let's say that you want to run degree 2 times, but the first time is for the whole network, and the second time we want to take out some elements and then run it again. Kumu will think that degree, because the field name is the same, you're running degree both times, it will basically overwrite the number that you used the first time. So this 13, let's say that in the second time in a smaller piece of the network, it's only 7. So Kumu will update degree to 7. But if you want to keep both numbers, then it's important to first change the name of that field. So if I click on this little drop-down arrow, I can say rename to, and I can, for example, call it degree 1, so that if I run degree again, Kumu will create a second field called degree, and both of those numbers will be saved. If you ever need to find this information again, how you would do that, it is also explained here, saving multiple versions of a single metric. So if you ever see your data being overridden, just know that that might be causing it. Okay, so we've looked at degree. Then here we kind of have the big 3 of the metrics. So these are the most commonly used: degree, closeness, and betweenness. As I just mentioned, betweenness is how many times an element is on the shortest path between 2 other elements. The degree is the amount of incoming connections and outgoing connections, and closeness is the distance each element is from all other elements. In general, elements with high closeness can spread information to the rest of the network most easily and usually have high visibility into what is happening across the network. So now we calculated closeness, and we can still see that James is pretty big at the top, though the rest of the ranking has changed a little bit. So you can basically go through all of these. Size looks not at how many connections an element has, but how many neighboring elements. So it might be that one element has a neighboring element. So in its proximity, but there's no actual connection between them. So it takes that into account as well. So that also allows you to see like where are the gaps? Like where are there elements that aren't connected that I wish were connected? The other one is in degree. In degree is the amount of incoming connections that an element has. Out degree is the number of outgoing connections that an element has. Eigenvector is how well connected an element is to other well connected elements. So we're in this case only like really focusing on those, like all those well connected elements. In general, elements with high eigenvector centrality are the leaders of the network, though they may not have the strongest local influence. And then lastly, a micmac is really an analysis of your entire network at the same time. It's based on very extensive algorithms that I won't get into right now, but micmac really looks at two separate things. The first one is element exposure, so how much a given element is affected by other elements, and the other one is influence, how much a given element affects other elements. So we're really looking at being affected and affecting others, and then all of that information is jumbled together, and based on that, there's an outcome that again allows you to identify leverage points within the overall system. Those are a couple of the different analyses that you can run. What you can also do, if we're looking at degree, for example, there's an advanced option to weigh connections. If we're looking at a network, not all connections are equal, right? For example, you may know a person, but that person is not your best friend. So the connection between you and that person is not that strong. It's limited. You know them, you know of them, but that's it. While the connection to your best friend is incredibly strong. So with weighing connections, we want to take that into account. So there's multiple ways to weigh connections. The first one is to simply give the connection a strength and then weigh based on that. If I were to do that, then you would see that reflected in the weight here. You would say weigh connections by strength. In this case, Kumu is suggesting that I weigh connections by any of the numerical fields that already exist. So any of the metrics that I just calculated, it's already included here. If I want to size by, I can size by a degree field. And now you can immediately see that the elements that are in the center are most well connected, which makes sense because they're in the center. You can see the different sizes, and that allows you to quickly see who the influential people are in your network. So that's really easy. Just click size by and then choose any of the numerical fields. If you're not seeing any fields here in size by, then it means that it's not a numerical field. So always make sure that you're first, turning it into a numerical field. Metrics are automatically numerical. That's the only thing they can be. So that's why you can see all these here. If I go through this, you can really see the sizes change based on the information. Community detection. This is again located under metrics. And if you click on community detection, Kumu is going to rack its brain for you and think about how many subgroups are in your network based on the connections. In this case, Kumu found 4 communities. There can be up to 10 different communities, but you can rerun this algorithm as much as you want as well. If I now click on any of the communities, I can see who are a part of this community and why. It's all based on strength of association. Again, it's all an algorithm in the back end of Kumu. And now if I click save, that information is again included in the profile of the elements. So now I can see this Mike is community 3 and Alexa's community 1. And now if I want to color based on that information, I can simply click color by and then choose community. I can choose also a different coloring that I like. In this case, there's one huge community that is number 1, and then there's a smaller one too. And the last one, the 4, is actually really a small community. As you were shown earlier here, it really allows you to see what the subgroups are and how they are connected. So now I can, for example, look at these 3 people and I can try to figure out, okay, why are they a sub-community? Why are they so close-knit? And if I want to make them more a part of community number one, who should I likely reach out to? In this case, I would probably reach out to James again because he's pretty well connected, and I might reach out to Jay. But you can also see that Jay and James are also part of different communities. So all of this just gives us a little bit of information about the structure of the network and how the lines of the relationships, how they kind of move and how strong they are. Once you have all this information, you can start thinking, okay, how am I going to act? So what we always say is that SNA provides you with the potential influencers, the potential leaders in a network, but you should then validate and do something with that information based on common sense, right? Because sometimes, like, at the end of the day, you probably know your community best, and you would look at something and feel like, that might not be right. But that makes you ask questions like, okay, but why does Kumu think that this person is a leader? And why do I not feel like they are a leader, for example? So it really allows you to answer all these questions about your network, or really the structures that you haven't thought of yourself. And based on that, you can then look at, okay, who am I going to reach out to? What other connections do I want to foster between people? Who do I want to help in their leadership role, for example? All of these different questions that you may ask. If we're looking at the central elements, usually there's two extreme ways that this can go. So the first one is that you have a bottleneck. So a person that has a lot of control over the flow of information and has a lot of power of how the rest of the network receives information. And there's also something that we call heroes. So kind of selfless people that just trying to help people in the network. And usually they come out as the informal leaders because they weren't really appointed to that in a way, but it turns out that they just are the person that other people in the network turn to. Then on the borders, you can have bridges, so people that cross gaps. And then there's also outsiders, so people that are on the outside, either intentionally or they're kind of stuck on the outside and they're not able to find their way into the network and be more interconnected.
Yeah, I do have a question. It's about like if I have a network, like exactly like what you're showing us, and they are working on different modules of a very large project. And I want to look at are the people who are overlapping on the same module. And when you were showing the community thing, I'm thinking, can I use the communities to kind of figure it out who are the people who are overlapping in their module?
That's definitely one way to go about it. One thing I'm thinking is that a person can only be part of one community. So what I would do is I would probably run community detection, and then I would look at the communities and look at the people and try to identify who are the people that are a part of one community that I actually see being stronger connected to another community. So that's how you can kind of find the overlap. It's not really a way that you can find the overlap mathematically with the algorithms, but it's more of like an interpretation that you can do after the fact to kind of like look at the colors and look how, from your perspective, if that's accurate or not. Because if you feel like, okay, Jane is part of this community, but I know that she's actually not that strongly connected to that community because she's more connected here, then that might be where the overlap lies. There's still a lot of other metrics out there that you can use that we don't have here, but we just have the most prominent ones, the ones that we feel are used the most, and allow you to do some research.